Hi guys. So, this is a problem found on page 19 under post test 2 where we asked to differentiate with respect to x using the implicit differentiation. So, there are two ways of doing this. The first one is when you notice that you can actually use the natural logarithmic laws. But if you don't know how to use those laws, you can start with this first particular method. So let's do that. Now, from what we have learned, we know that if we have y is equal to ln of a function f of x, then we know that dy over dx is equals to 1 over f of x times the derivative f of prime of x. Now, there's one thing I have noted, right? Most people don't put this derivative in brackets like this. Make sure you put it in brackets like this so that when you multiply it with this term, you don't get confused with some of the terms. So let's do that. In this case, our f of x is what? Our f of x is equals to the square root of x squared plus y squared, right? So this can be written as x squared plus y squared to the power of half. So then it means that if we start differentiating the left-hand side of this expression, then we have 1 over x squared plus y squared to the power of half times the derivative of this function here, right? So what is the derivative of that function? So as I said, put everything in brackets. So the derivative will be, take half this side, so this will be 1 over 2, subtract, put everything the way it is, so x squared plus y squared. So basically we're using the chain rule, right? Times the derivative of, put in brackets as well. That is times the derivative of x squared, so that will be 2x plus the derivative of y squared, that will be 2y. But because we differentiated y, therefore we need to multiply by dy over dx. Remember, y is a function of x, right? So this is the left-hand side. This is equals to, now let's differentiate the right-hand side. The derivative of x is 1. The derivative of y is also 1. But because y is a function of x, therefore we multiply by dy over dx. Okay, so let's write our expression properly. So this is equals to, no, sorry, not this is not equals to, but let's simplify it. So this is 1 over x squared plus y squared to the power of a half times 1 over 2 times this expression over here, right? This expression that's highlighted. This expression over here can be written as a fraction. And what do I mean by that? Remember, if you have a to the power of 1 over 2, this is the same as 1 over a to the power of 1 over 2. So we can write it like that. So times 1 over x squared plus y squared to the power of a half times this expression over here, which is 2x plus 2y times dy over dx. So we can also make it a fraction if you want by dividing by 1. So then this is equals to 1 minus dy over dx. So from here, we can see that we can multiply 1 times 1 times 1 times this expression over here. So multiply all the numerators. So let's do that. So this gives us 2x plus 2y times dy over dx, close bracket. Now let's multiply the denominator. So we have this times 2 times this one over here. So meaning that this will be equals to over this 2 over here. Now note something. Remember when we had a to the power of 2 times a to the power of 3, we said, according to the exponential laws, same basis, if we are multiplying, we add the exponents. So 2 plus 3. So this is a to the power of 5. Meaning that now we are multiplying this term over here and that term over there. So this is x squared plus y squared to the power of a half times x squared plus y squared to the power of a half. So if you now we have same bases, what do we do to the exponents? Because we're multiplying, we add them. So then this is x squared plus y squared is equals to a half plus a half. And we know that a half plus a half is equals to what? Is equals to 1. So therefore this would just be equals to x squared plus y squared to the power of 1, which is just x squared plus y squared. So then we write it here. So this is x squared plus y squared to the power of 1, if we want to still write that 1. So then this is equals to 1 minus dy over dx. Now let's try to simplify. So then we multiply by this 2x squared. Sorry about that. So then we multiply this 2 times x squared plus y squared both sides, so that we then remain with 2x plus 2y dy over dx equals to 2x squared plus 2y times 1 minus dy over dx. Are we all together there? Sharp, sharp. So now, let's simplify this term here so that we can take all the dy's to the left hand side, dy over dx to the left hand side, and the terms without the dy over dx to the right hand side. So then we have 2x plus 2y dy over dx equals to, now this term here multiplies with this one. So then we have 2x squared plus 2y. Why do we have, sorry, why do you have, oh, no, this is x squared. So this is x squared because remember we multiply by 2x squared plus y squared. So this is y squared actually. So this is, sorry about that. So this is y squared. There we go. Okay, I made a mistake here. So this is y squared minus 2x squared plus y squared times dy over dx. Okay, now let's take everything that is a dy over dx to the left hand side. Let's take everything that doesn't have dy over dx to the right hand side. So in this case, it means we remain with 2y dy over dx. On the left hand side, take this term, then that will be plus 2x squared y squared dy over dx. Now here on the right hand side, we have 2x squared plus y squared. But here, this doesn't have a dy over dx. We take it to the right hand side minus 2x. So now on the left hand side, let's fix out dy. So we remain with 2y, let's put it in brackets, plus 2x squared plus y squared dy over dx equals to 2x squared plus y squared minus 2x. So let's divide this entire term here by itself. So 2y plus 2x squared plus y squared. And remember, what you do on your left, you do on your right hand side as well. And then that is 2y plus 2x squared plus y squared. So then we have that dy over dx is equals to 2x squared plus y squared minus 2x over 2y plus 2x squared plus y squared. Now from here, you can notice that we actually have a 2 almost in every term from the numerator as well as the denominator. So we can factor out the 2. So let's do that. Let's take out the 2. So we take out the 2, then we remain with x squared plus y squared minus x. At the bottom, we also take out the 2, so remain with y plus x squared plus y squared. So this 2 forms a 1. So therefore, your dy over dx is equals to x squared plus y squared minus x over x squared plus y squared plus y. So that's the first part. That's the first way of doing it, right? So that is if you didn't know any laws of the natural log, right? But let's say you know the laws of the natural log. So then you can apply that. So let's do the second way of doing it. Okay. Let me paste the question here, right? So now you know the laws of the log laws, right? So you know that if I have ln of a to the power of n, then this can be written as n ln of a. Good. So meaning that here we know that this can also be written as x squared plus y squared to the power of a half equals to x minus y. So then using this log law, we then say 1 over 2 ln of x squared plus y squared is equals to x minus y. Then we have simplified the expression. So then we can start with our implicit differentiation. So as we said again, as we know that if we are given y is equals to ln of function f of x, then the derivative of that dy over dx is equals to 1 over f of x times f of prime of x. And always put the derivative in brackets so that it will be easier for you to simplify and then you don't get confused with some terms. So this is equals to, now let's differentiate. So we have 1 over 2, put in brackets, this term, differentiate this whole part. So this is 1 over x squared plus y squared times the derivative of what's inside here. So the derivative of x squared, it's 2x plus the derivative of y squared, it's 2y. But because y is a function of x, therefore we need to multiply by dy over dx. Okay? Now, let's differentiate the other side. So this is 1 minus derivative of y is 1, but because we're differentiating y with respect to, since y is a function of x and we're differentiating it, therefore we multiply by dy over dx. Now, let's simplify. So here, you notice that, okay, let's make this a fraction as well. Let's say to the divided by 1. So meaning that you're going to multiply 1 times this whole expression here, right? So this will be equals, and then you'll also, okay, let's just do first the top part. So then this will be 1 times 2x plus 2y times dy over dx. We have 2x, so that will be 2x plus 2y times dy over dx. Over, now we multiply the denominators. It's 2 times 2x squared times 1. It will be what? It will be 2 times x squared plus y squared. So then this will be equals to 1 minus dy over dx. Now we want to simplify so that we can be able to write the dy's on the left-hand side and everything else on the right-hand side. Here, from here, we can notice that we can multiply by 2 times x squared plus y squared both sides. So this will be equals to 2x plus 2y dy over dx equals to 2x squared plus y squared times 1 minus dy. You see how I put things in brackets? Because I don't want to confuse myself at some point. So now this is 2x plus 2y dy over dx. This is equals to, now this is 2x. So this term here, 2 times x squared plus y squared multiplied by 1. So this is 2x squared plus y squared. Now this term again multiplied by dy. So this is 2x squared plus y squared times dy over dx. Now from here, we know that those terms that have dy over dx to the left, those that don't have dy over dx to the right. So let's do that. So it means this term remains. So we have 2y dy over dx. And then we take this term to the other side. So it's plus 2x squared plus y squared dy over dx equals to, this term remains on the right hand side, 2x squared plus y squared minus this 2x minus 2x. Now let's factor out dy. So we have 2y plus 2x squared plus y squared dy over dx. So this is equals to 2x squared plus y squared minus 2x divided by 2y plus 2x squared plus y squared. And what you do on your left, you do on your right as well. So it's 2y plus 2x squared plus y squared. So then you have that dy over dx is equals to 2x squared plus y squared minus 2x over 2y plus 2x squared plus y squared. Now you'll notice that here we have a 2 almost in every, both in numerator and denominator, that we can factor out, and then it will cancel or form a 1. So therefore, then we can factor out a 2 from the numerator and factor out the 2 from the denominator. So let's factor out 2, meaning that we remain with x squared plus y squared minus x. Let's factor out a 2 here, 2y plus x squared plus y squared. So then this will be equals to, so this 2 cancels that 2 or forms a 1. So then we remain with x squared plus y squared minus x over x squared plus y squared plus y. Therefore, dy over dx is equals to x squared plus y squared minus x over x squared plus y squared plus y. So whether you knew how to change this term over here, where's that term? Whether you knew how to change this term over here, the natural log, right? Or you didn't know how to use this law basically, still you could have been able to actually differentiate. So those are the two ways that you can differentiate this problem using implicit differentiation. Thank you very much.